right, so we're going to start rotating around a line that's other than the x-axis and the y-axis, so around a different axis. So this example, this is in your notes. We go through and sketch the graph for this. Looking at something like this. X squared, negative x squared plus 6x is going to be a parabola that opens downward. Vertex is right here at 3, 9. And the line y equals 5. Y equals 5. And then we want to rotate this around that same line, y equals 5. So my shaded region is going to be this part right in here. That's the piece that's enclosed. And then I want my rectangle to be perpendicular to the axis of rotation, so it's got to go vertically. So that's what I'm looking at. You need these 2 points of intersection. You can plug that into your calculator and get those points of intersection by using second calculate, and number 5 is intersection. So those are my points of intersection. So my volume is going to be from 1 to 5, that rectangle range from left to right from 1 to 5. I need my radius. So my radius for this one, the rectangle touches the axis of rotation, so this is going to be a disk method. There's no space between the end of the rectangle and the axis of rotation. So my radius is going to be the end of the rectangle touches the parabola, which was the negative x squared plus 6x, minus the end of the rectangle that touches the curve there, which is 5. So my radius squared be that negative x squared plus 6x minus 5 squared dx. And then you can use your calculator to integrate that. Otherwise, you're going to have to multiply that whole thing out. So let's put that in the calculator then. So it's negative x squared plus 6x minus 5. That whole quantity is squared, and we're going to integrate that from the lower bound of 1 and an upper bound or upper limit of 5. My calculator gives me 34.133. We can convert that to a fraction. Enter. 512 over 15. So my volume will be 512 over 15, and then don't forget the pi out in front, multiplied by pi. So I got an exact value for that volume. So that's a disk method when the axis rotation is something other than the x-axis. If I do the same idea with a washer method, I'm going to have some space in there. So if I look at this graph, 1 over x, and x equals 0, y equals 0, which is the x-axis. X equals 1, x equals 4, and we're going to rotate this around the line y equals 4, that's up here. Right, my enclosed region then is going to be, let's see, my enclosed region is this piece down here. I draw my rectangle perpendicular to the axis of rotation. I'm looking at my 2 radii. I have a big radius, end of the rectangle to the axis of rotation, and then I have a little radius, the other end of the rectangle to the axis of rotation. The big radius, this distance from y equals 4 down here to y equals 0 is 4. My little radius is from the axis of rotation, which is 4, to the curve, which is 1 over x. Since you're finding that distance, you're subtracting those 2 values there. So my volume would be pi. Bounds for integration, x goes from 1 to 4. The big radius squared minus that little radius squared. And again, again, you can put that into the calculator. So let's pull that up. So I have 4 squared, I'm just going to type it in as 16, minus that quantity, 4 minus 1 over x needs to be in parentheses as well because it's a fraction. That second term there, 4 minus 1 over x is squared. And then we're integrating this from 1 to 4. Lower limit is 1, upper limit is 4. I get this 10.304, let's change it to a fraction, so math 1 is fraction. So it gave me this 90,323 over 8735. So I remember 90,323 was 8375 times the pi out in front. Your calculator may not be able to handle a fraction with such large numbers, and it might give it to you as a decimal, and that would be okay too. And then the last one, this one's not in your notes. This one's the same idea. The only thing that's different is now when we set this up, we're rotating. Our rectangle is going to be horizontal instead of vertical. So if we graph this, the equation y equals x minus 4. This is backwards. This should be negative x and plus 4 is what I want it. So positive 4. So it's going to be this line. Y equals negative x plus 4. X equals 0 is the y-axis. Y equals 0 is the x-axis. And we're going to rotate this around the line x equals 6, which is out here. So if I draw my shaded region then, I'm looking at this area in here. And then I want to draw my rectangle perpendicular to the axis of rotation. So perpendicular to the axis of rotation is going this way. So now I'm working with y values. So I'm going to have to take this equation for this line, y equals, it was negative x plus 4. I'm going to have to rearrange it so it's x equals. So if I rearrange that, it would be x equals 4 minus y. Put the x on the left side and the y on the right side. So my big radius, my small radius, from my axis of rotation to the end of the rectangle, so 6 minus this equation down here would be 0. My little radius is going to be the end of the rectangle closest to the axis of rotation, so right minus left would be 6 minus this line here, which we said was 4 minus y, which needs to be in parentheses. So my volume then would be pi. Y now ranges from 0 to 4. My big radius was 6. My little radius is 6 minus 4, which is 2. And minus a negative y squared would be plus a y squared. And then you can put this in the calculator, or you could integrate it by hand. I'm going to put it in the calculator. Now, when you put this in the calculator, it's not going to be the same equation or the same graph that you're looking at, because that's not the graph that we're integrating. We're integrating this thing, big radius squared and little radius squared. So 6 squared is 36, and then it's 2 plus y. We're going to have to use x. And that's squared. And we're integrating this thing from 0 to 4. It gives me 74.666 that repeats. Let's convert that to a fraction. 224 over 3. So it's going to be 224 over 3, and then this pi out